Here we go. Well, welcome everybody to multi-user editing with QGIS and PostGIS in an enterprise environment. Excited for this webinar. This is something that I've presented on a few times before, but I never put it together as a full webinar. A lot of the components that we're going to talk about today are part of our training courses that we do when people sign up for a server, especially with us. So there's a lot here and there's a lot of material that I'm going to be going through. The Q&A is open on Zoom. Feel free to drop a question on throughout the webinar and I'll try to answer them in the end if I have some time. Otherwise, my email address is on the screen now and you also see it on the last slide. And feel free to email me anytime if there's something that comes up that you want to ask. Chat is also open. If there's ever any issues, you can post them there. But with that said, we're going to get going. I'm just going to turn off my camera so we can see the full screen. All right, so a little bit about Luna Geospatial. We provide consulting and training for everything open source GIS. So QGIS, PostGIS, GeoServer, these are our areas of expertise, also remote sensing. We provide a number of training courses, online instructor-led courses, and we're slowly moving towards offering some of our courses on a virtual platform. We also provide support for all of these software. This is sort of pay-as-you-go support that we offer a number of different companies and organizations. We also do software development. Our software development developers build web GIS, dashboards, data portals, mobile first applications, really anything that's a complex data-driven application. We have our hands all over it. And when we do, we build most of these tools, or I should say all of these tools are built with open source GIS software. The other thing that we offer are GIS servers. These are fully managed cloud-based servers. We provide backup, support, training, you name it. And with these servers, we install things like PostGIS and GeoServer and all of this other wonderful open source GIS software. We have a number of clients across Canada and across the world. This is a snippet of those clients that we work with on a regular basis. We're doing some really exciting work right now with the Nova Scotia Federation of Agriculture, building a really nice web app for them. We've been working with Birds Canada since we started, and they recently launched a new data portal that we were a part of building. And we work with a number of other organizations, including universities and other nonprofits. We do have a newsletter. This is where most people find out about our upcoming webinars and other things that we put out there. We try not to spam. We don't. We send maybe 1, 2, 3 emails a month, depending on how busy we are with things like training and other things that we're offering. But for the most part, the newsletter is just a list of whatever webinars are coming up or other events that we're planning on hosting. The next webinar after this one is called Open Source GIS for Local Government, 6 Practical Examples. And I wanted to do something a little different with this webinar. Instead of just talking about the software and what the software can do, I wanted to show a few good case studies for local government. So we're going to talk about things like asset management, flood risk analysis, census analysis, and so on. There might be a few other topics that we'll throw into there. I always tend to make a list and then I sort of add to it. So it might end up being like 8, but we'll do our best to get through all of that material. You can head over to lunageo.com/webinars to sign up for that one. As well, when you're there, you're going to notice that we have all our past webinars online. They're all on our YouTube channel. So if you do navigate over to our webinars page, you'll see a nice list of everything that we've done over the past few years. And there's really a lot of material there that you can go through. All right, intended audience for this webinar, anyone who needs a solution for concurrent multi-user editing of geospatial data. That's pretty obvious. And anyone, but this is also for those people who are considering migrating to open source GIS. Maybe you already have a solution for multi-user editing, but you want to move to open source GIS and you're sort of wanting to know what else is out there. How would you actually set this up using open source GIS? So one thing to note is that when I do anything on a database, I'm doing a lot with SQL, the lingua franca of the databases. And so this webinar is kind of SQL heavy, and mainly because I want to be able to sort of show you what happens or what commands are actually being run, what statements are being run on the database when we're doing these things like setting up different permission systems. So it's really good for you to see that. But I will note that all the statements I use, you could probably execute them via the graphic user interface in something like PG and Min 4. So you just have to hunt around, but this will give you at least the core concepts that you need to know in order to do wonderful things. All right, so I've worked in a number of different GIS settings, and I think the sort of holy grail of enterprise GIS is definitely this idea of seamless and concurrent multi-user editing in an enterprise GIS environment. Not only do we want to allow multiple users to connect and edit and change things, we want to be very granular with those permissions. We want to say user A can do all this stuff, user B cannot do these things, user C, we have no trust for that person, they can only read data, and we want to make sure our data are locked down. Not only that, we want to be able to track changes. We want to audit the data. We want to be able to say, okay, when was this changed? Who changed it? Why did they change it? Is there some sort of note as to what happened? Why are there 16 parcels missing here? We need to know this, and we need to know who made those changes and why. So what we often get instead, and I've worked in these environments too, and seen these environments where we just have a file-based GIS, there's a single user, a single user is best for these environments, but anything more is chaos. And you just end up with a whole bunch of crummy data that's shoved into a folder, and it just creates problems. So building an enterprise GIS database in 6 steps. This is pretty much the process we go through with most clients. One, we start with building the database. We design the database. Then we work on migrating data and your workflows to this new environment. We establish permissions. We figure out what features need to be automated. Do we need trigger functions to automatically populate some field? Do we need to create some custom functions that we need to run in order to perform some sort of major feat within the database? We need to set up the backup system. How are we going to back up? How are we going to restore the data? And then we also need to work on, once we have the database set up, is we start working on QGIS integration. And this is things like building awesome forms that you can use for entering data, saving default symbology to the database and things like this. And I'll go through all of this stuff with you today. So I'm going to start with a demo, and I'm going to show you one that we've set up to show you. It pretty much does everything that a multi-user editing environment needs to do. And we've included a lot of kind of neat features in it. So the first thing we're going to do is we're going to look at the database structure. So this is a typical structure for like what I call like a data warehouse type situation, where you have one database, you have a bunch of schemas, and this is pretty much what it looks like. If we go into PG and Min here, we have a database called Kamloops demo. So we're going to use a bunch of Kamloops data for this demo, and in it we've created a number of different schemas. If you're not familiar with databases, just think of a schema for now as a folder, but it's not a folder. There's a lot of things that happen with it, but it's a place where we can put stuff. So in the boundaries schema, let's just say if we expand this and we expand tables, we can see that we have the city boundary, we have city properties, we have neighborhoods, postal codes, property parcels, and these are all just open data that I brought in and added to this database. So this is pretty much the structure that I start with most organizations that want this type of sort of data warehouse situation, where they have a whole bunch of data, they want it out there, they want people to be able to use it. Maybe there'll be a little bit of editing going on with these data sets, but for the most part, they just want to be able to serve out these data. This is different than like a project-based database where every schema might be a different project, and then each database might be a different year. Really, we have to go through a long list of questions, which I'll get into in a little bit. All right, so we have our database structure set up, but we want to have concurrent editing. So what we have at this point is a database where we can go in, we can add any layers we want. I like adding the property parcels onto the map. So this is being pulled directly from PG and Min, of course. And I'm loading now. I will tell you, I'm loading now as we have a bunch of different users. So I've set up profiles for different QGISs. So if you see me switching between, right now we're looking at this as admin, and then I'm going to switch over to Sarah. And Sarah is a editor, and we're going to load the property parcels as well. Property parcels gets loaded as Sarah. She has access, and then we have John as well, and John is also an editor within the database. Again, we notice that the symbology is the same as we go between users, and then we have Phil. Phil we don't trust. Phil is a reader. Phil cannot edit almost anything in the database, but we will get to some of the things Phil can edit. So if we load this layer, we can see that there are, it can be loaded by any user within the system. So we're going to go back to the admin. So the admin right now can actually make edits. This is going to be, I'm going to load another layer actually that we're going to edit. We're going to load the city boundary layer. It's just a polygon, goes around. We're not going to use the properties simply because I have another little trick that I want to show you later on with the properties. But with the city boundaries, I can come in, I can edit, I can create a new polygon. Okay, right here. There are no required fields. I can press save, and now I have this new polygon. What's neat is now if I move over to where Sarah's system here, and I bring in the city boundary, this new polygon that was just created by another user is now visible here. And likewise, if I move to John, of course, you'll get the same thing. John has the exact same permissions as Sarah. And then if we move over to Phil, you guessed it, Phil also has this new polygon. But what's nice now is that once we get into an editing environment, Sarah here, you can see has the editing tool available. The toggle editing button is there. If we click on, oh, sorry, that's hard to see right now. If we're on Phil, you do not see the editing tool. The editing tool is not available. With John, it is. With Sarah, it is as well. Right, so if we click on the editing and we modify this polygon ever so slightly and press save on our edits and we move over, oh no, that change hasn't happened. It has. We have to actually refresh, and we press refresh and that change will now take place. And same thing with the reader user is now going to see all of these changes taking place in real time once you press refresh. Now that change will also be visible if you zoom in and out. It'll re-request the data and be loaded. So right now we've just created a multi-user environment. If we wanted to stop there and say now everybody can edit, some people can edit, some people can't edit, we've solved like 90% of the problems for most of the clients we deal with. This is it. Okay, but of course there's more. Okay, so what about schema level permissions? This is kind of nice too, is that within each schema, we can control who has access to which tables. Now, if I open up this admin schema, and I hope you can see this, I am on 32-inch screen, so sometimes things are quite small, but I'll read out the names here. We have a point file called admin stuff. We have another point file called other admin stuff, and then we have a bunch of other files down here. Now, if I'm looking at this as the admin, right? So I'm logged in as the Postgres user, the super admin within the server. If I go over to Sarah, and I'm just going to minimize some of these, and I maximize the admin stuff or the admin schema, I can see that only admin stuff is available. Whereas with the when I'm logged in as the admin, I have that other file, other admin stuff, also available. So you can guess that if we look at this as John, the other editor, he also has only access to the admin stuff file. Now, if we go over to Phil, who's just a reader, he can't even access that schema. So what's nice here is that if you want to hide files or layers within your database, you're able to do this. They might see the schema, so you might have that schema called admin, but within it, you don't necessarily have to expose those files. Even if somebody has access to the schema, like our editors here, they will not be able to see all the tables unless they have the select permission on those tables. So here's another thing we can do. We can hide data within your database, not expose everything to every user. We can work with default symbology. I show this a lot. We have our city boundary right here, and right now it's set to purple. I can modify that within QGIS. This is how QGIS is really well integrated within PostGIS, and say, okay, purple, I don't like. Let's go with green. And I'm going to press apply, and I'm going to look at it and say, green is beautiful. I love this. Let's go back into in here, and we're going to save as default. And it's going to ask us, where do you want to save it? We're going to save it in the data source database. And we're going to say, do you want to overwrite? Yes, I want to overwrite. It's going to overwrite over that purple one and set this one as our default. Now, what's neat about this is that if I close this and I go back into our boundaries and I load our city boundaries, now everything's loading in green. Now, the only person who can save, because I've set this permission up, the only person that can save symbology like this is the admin. Because if we have too many people changing the symbology, all of a sudden there's no standard within your organization anymore. Everybody's just changing things to whatever color they want. This doesn't prevent you, of course, from changing it within QGIS. If for a specific map, you want this to be a black line, let's say, you can still do that. But when you load the layer from the database, it loads with that default style. Now let's remove this and let's go back in. So now we're logged in as Sarah, the editor, and we load the city boundaries. Now they're green because that has been established as the style. Now, I honestly cannot remember if I gave the editors the ability to change any of these styles, but let's say we wanted to change it to orange. Okay, so we've changed it to orange, but we want to save that as default. I'm doing this now as Sarah, the editor. If I go to save as default and I press data source database and I try to overwrite it, hey, it works. That's excellent. So I can show you over here now is that if we go over to Phil has no ability to edit anything. Unless I really screwed up on the permissions here. Oh, actually, no, this is fun. We did not actually save that style. So it says, sure, it's saved, which is kind of funny. I wish there would be an error. Most things with the database that will throw you an error if you're unable to edit or save. But that save we did with Sarah did not actually save because when we go to re-add the style, we can see the default is still green. So symbology is really important. Saving things as default within the database, it just makes it a lot easier for everybody using it. You can save multiple styles. I've talked about this a ton in other webinars too, so I won't go over this too much, but there's a lot to this in creating your default symbology. So what about attribute forms? This is super easy. I do this all the time for clients. I like to make things as clear as possible when they're loading up layers and when they're identifying. So the default pop-up that will show up is this, right? So you have this default sort of form that pops up with everything in it. If you want to change that, it's very easy to go into the settings. You go into attribute form. You can create a drag and drop designer and create a bunch of different groups and say, you know, I'm just going to call this tab 1. We could probably think of more creative things to call it if I wasn't doing a live demo. And we can grab a bunch of these and we can move them to, or sorry, not all of them. Let's just say half of them to PID. We're going to move that to tab 1, and then we're going to grab the rest of these, and we're going to move them to tab 2. Now, with each one of these, you can create different widgets, or you can add different widgets, as they call them. So you can have drop-down menus, you can have checkboxes, you can have date pickers, you can have really anything you want. You can even have conditional logic. You can say, well, if somebody answered 7 to this question, show these other fields that they have to complete. So I did this with a surveying app once where I was trying to record metadata related to points that we collected. So the first question was, how did you collect it? Did you use RTK? Did you use a total station? Did you use this? Did you use that? Just to give us an idea of the accuracy of the points within our data set. So if I press OK on this and then I come back and I identify a parcel, we can see we have 2 tabs now. So it's sort of splitting the metadata, splitting the attributes into 2 fields. And when you save this as default within the system, this will be visible to anyone. So the form that's saved is saved as part of that default symbology. It's really quite handy. All right, I'm not going to save that for now because I want to show you guys some other stuff. All right, what about saving QGIS projects to the database? One of the things that's nice is we can do exactly that. So I've created this map schema, and I have a Kamloops base map schema that I can load. It has a OpenStreetMap base map. I have the parcels. I can turn on all of the parks and rec data if I want. I can turn on all of the transportation data if I want to have the roads on the map. I can even turn off this. I can turn on hydrology, and we have pretty much a nice base map that doesn't use any OpenStreetMaps anymore. We could probably sexy this up a bit if we worked a little harder on it. But this is it. We're loading all of our layers directly from the database. You're seeing this as admin. If we go to another user, Sarah, the editor, Sarah, the editor can also load this base map. You guessed it. John can also load this base map. Oops. And oh, hey, look at that. This is fun. I love doing live demos and having things like this pop up. So there are some permissions that just weren't turned on for this user, which worked 5 minutes ago. All right, so creating projects is actually really easy when we're working here. We can simply go in and we can do save to instead of save as. So instead of saving your QGIS project directly to your file system, you can do save to Postgres. I'm going to save it in maps, and I'm going to call this, let's say, Kamloops base map 2. Press OK. And if I press refresh here now, we're going to see we have 2 maps. This is nice because it centralizes everything within your database. Now, where it gets complicated is if multiple people are working on the same map, then we have some issues, because how it works is the last save wins. And that can be a problem. So we just need to make sure that there's very few people who are editing the actual projects. Now you can edit the data in the project, but if you're editing the project itself, then everybody else's saves are going to save over. So you just have to be conscious of that when you're setting this up in an enterprise environment. All right, column level security with notes on parcels is a really cool feature. So this is where certain users can update certain fields within a layer. So I have it set, of course, that the editors can edit everything, but if we get over to Phil, that was just causing us problems. So we just want to make sure that hopefully this works fine, or else this demo is just going downhill. All right. Ooh, fatal error. Ooh, look at that. All right. I'm going to skip over that one because this is causing us a problem with Phil. All right, so this is basically with row level security, as we're able to, column level security, is that we're able to control how users can edit specific columns. So originally, actually, I know what I'm going to do. I realize what's going on here. 1 second. All right. So what we're able to do is we're actually able to control how certain fields are edited within this environment. We're going to see if this is going to fix up our little problem here. And it did. Look at that. All right. So I'm going to load now just the property parcels. Okay. So we have the property parcels in. Now, remember, Phil is a read-only user, so he shouldn't actually be able to create anything. So if I go in and I want to create a new polygon, I can't. I can turn on editing, but I can't actually edit. The button is not available to actually create because this user does not have permission to do that. The only permission that I've given Phil and all readers is the ability to enter a note related to a parcel. So we're able to go in and we're able to use our identify tool. Nope. Zoom in more. And we're able to scroll down to this notes field and say, this is a note, and press OK on this. And I'm able to press save and commit that change to the database. So now if I look at it, I've turned editing off. I have this is a note saved. But if I went in and I clicked on this and tried to save this as block 88 and press save and make that change, it's going to throw up an error. And if you read your errors, which you should, it tells you that permission denied for table property parcels. Phil is not able to make any other changes on that table except in the notes field. So this is a really powerful feature that we can use in an enterprise environment because we're able to really have this granular control over how users can interact with the data. Maybe they can only add a few fields. A really nice application in a GIS environment is to say, you can't change the geometry. These survey points were surveyed. We don't want you to accidentally nudge a point. These were surveyed with an RTK. The points are fine. We don't want you to move them, but we want you to be able to edit all of the attribute data. So you'd be able to lock down the geometry field, lock down the ID field maybe too, and then give users the ability to edit any other field within that attribute table. So it's really powerful stuff, and there's a lot of applications for it. The other one is row level security. So with row level security, we're able to control really who can add different fields within a or different rows within a project. So I created this like work order system. It's not really a work order system. It's a couple of fields in a database, but I created a table called work orders. And if we identify this, we can see that we have a variety of fields that we can put in. It's a work order type as inspection. It doesn't really matter, but we have these metadata fields created by, it's automatically generated with a trigger function to put the usernames in. So in this case, it's John. But I'm looking at this as the admin and I see 2 points here. What's interesting is that if we go over to, right now we're on Sarah. So if we look at Sarah, who's an editor, we can see only 1 point. Furthermore, even if we open up, oops, wrong button. Sorry about that. Zoom's in the way. All right, so even if we open up the attribute table, we can see there's only 1 row. Cannot see the other ones, even though the same table is loading as 2. As admin, you can see everything. But now if we go, and you could probably guess, if we load this as John, John can only see John's points. So if John turns around and adds a new point, pretty basic, table pops up, pressed OK. We press save, turn this off, identify, come back to this. You can see that I've automatically populated this field created by and added John. If I go over to Sarah, even if I refresh, I'm still not going to see that new point because we've locked the rows. Sarah will only see rows that have the name Sarah in that one field. Whereas now if I go to the admin will see everything. So in a scenario where you're working on a large project and you don't want all your different users to be able to see the data that the other users are creating, this is a really nice way of doing it. An application like this for a work order system is also nice because even from the other end, from the management side, you could create a work order and then like assign it to somebody just by using a drop-down menu and saying, this one's for John. And as long as you change that field to John, then that work order would only appear for John. Now, of course, we could build this out and turn it into quite a bit more of a complex setup. Okay, default permissions when creating tables in the share folder. This is great. We created a little share folder or a schema right here. Has nothing in it right now. But when we add anything by default, if we add any layers to a schema, the owner of that layer is the only one that can really see it, right? Unless we assign default permissions. So what's nice now is that if we go in and let's say, I'm going to clear this. We're in as Sarah right now. Zoom is always getting in my way and I can't see which user I'm on. So now if Sarah did want to bring this file, I'm just going to do this the basic way and I'm going to slide this into the database. Import was successful. And now we have this layer, which is the healthcare centers that is loading directly from the database. Sarah can load it. But what's neat about this now is that the default settings are created so that if I refresh this schema as any other user, they can then see them right away. So even as Phil can see and load these layers, which is kind of nice. So we're able to do that through Postgres by modifying the default permissions. And I'll show you in a little bit if we have time to get through how we set that up. Automatically calculating parcel areas. Trigger functions are great. I use trigger functions all the time when I'm building a database. If we add something like our parcel data set and we zoom out, and let's say we were going to add a new parcel right here in the middle of the river. If we add this parcel, if we identify it before we press save, we'll note that down here, this area square meters is blank. If we press save on this, you guessed it, it'll calculate the area in square meters. Now, that's the tip of the iceberg of what we can do. Because we're working with a spatial database, we can do hugely complex queries. We can do things like, nearest neighbor analysis. We can count things. We can say, I'm going to put a polygon here, count how many trees are within it. If you have a tree point layer underneath or something, really, there's no limit to what we can do with these functions. They're really quite handy when we're building solutions for clients. Last one, data auditing on the property table. This is one that is really nice because, again, I was mentioning to you, one of the nicest things about working within a database system is that we can monitor changes that happen within it. So we can load things like property parcels, and we can say, all right, this new parcel that was just created in the water is still here. Wonderful. But I want to audit. Now I have this audit schema, and I'm here as Sarah, if I am correct, yes. I want to create another parcel, right? So if I want to create another one right underneath it, let's say, I'm going to press OK, press save on this. Now I've created this new parcel right below it. Now I can't see the audit table. That's locked down. Only admin can see the audit table because we wouldn't want anyone to accidentally delete anything, and we might use it to actually monitor progress on a certain job. Now, of course, if we go over to any of the other users and load this same layer, we'll be able to see these two property parcels that were created. But here's the thing that's kind of neat, is that if we go and look at the audit table with the admin credentials, so now we can see it, is that now we are loading up the, we can see the changes that have just taken place. So Sarah created she created a new feature with an insert statement on the property parcels data. So keep that in mind. So now if we go over to, let's say, John and edit it, and we're going to say John's going to come in and modify this, press save and close. So just change the geometry. And we come back to this table and refresh it. We can see now that we have an additional row John created, and we can see that the command, the query that was run, was an update. So did run an update, modified the geometry. Now, if John then also came back and said, you know what, that's a silly parcel, and said, I'm going to delete it. Since John has the permission to delete, we can come back to here and we can say, oh, look. Oh, I did that as Sarah. Sarah deleted the parcel. So now we can see that Sarah made that change. So what's nice here, a lot of things that are great here. One, we have the original data. So if something was deleted, we have the original data before it was deleted. That's all saved within the original data field. The new data, if we've made some changes, is saved into the new data field. And then we have an idea what the query was. And we can also see what action. It was a delete action. So if somebody accidentally, put their elbow onto the delete button on their keyboard and deleted everything, we would have a record of that. And that's a really powerful feature, especially in an enterprise environment. The one added bonus of that is I've had to restore stuff from these audit tables before, where somebody's just like, I think I changed the name of something. That's a really easy one. Instead of trying to restore a backup and trying to find that one feature, we can just go in here and say, oh yeah, it was the Johnson farm. Let's change it back to Johnson farm. All right, so how did we create this? I'm going to run through so much material right now, so I apologize if I speak very fast, but I want to get through some of this so you have an idea of kind of how we build these types of multi-user environments. First one, let's just go over this quickly, but this is the area for IT. Somebody's going to have to think about network security. Now, when we set these things up, we set them up on cloud-based servers, and we go through a lot of things, but we can set up network security at the Postgres level. We can set up a firewall and lock it down. If you wanted to lock your database down to a specific IP, we could do that. If you want to get big and fancy, we can also set this up on like a VPN if you really want to have a secure connection to the server. What about database design? Now, we went through this. We often talk to clients about what coordinate system are we going to load the data in. It might be many, it might be one. We might have a standard. We might have to transform data as we load it. I always ask, how will the database grow in the future? Are there going to be more schemas? Are there going to be more tables, more data in the tables? All of the above. I like to know because it's really bad. You want to make sure that whatever database you build is future-proof. Is there going to be one database or multiple? In the data warehouse model I showed you, that's one database. Maybe we'll add a new schema one day if we want to add something for like geology or soils. But for the most part, all the data that we're going to collect is going to be added to these, and maybe we'll update some of these data over time. Or in a project environment, we might create a database for every year, and every project from that year is going to have a different schema within the database. We got to talk about schema organization. What are we going to name them? What are we going to put in them? Table organization. Where are we going to put the tables, specific tables? We got to plan that. Do we create views or something called materialized views within the database? Are we going to create trigger functions, those fancy automations that allows us to automatically populate fields and do other magic within the database environment? What about data auditing? Which tables are we going to be monitoring? Are we going to monitor everything? Are we going to monitor specific tables within the database or none? Database design, we're going to import data. I will often use QGIS Database Manager. There's a lot of things I like. It's a GUI, it's easy. But you can also we also use the command line. If we have a lot of data, we might run a script and just load things. And there's a couple of cool command line tools, shape to PostgreSQL, and also OGR to OGR will do the trick. Part 3, user and group roles in PostGIS. So what we did is asked a bunch of big questions. Whenever we approach a client, we have to ask these same big questions. So who should have read permission? Who should have write permission? Are there layers that require more granular permissions? Are there sensitive layers that need to be protected? Who should have delete or truncate? Truncate is delete every row within a table, permission on each table. Who should have the ability to create or modify tables? Who can create, update, deactivate, and delete users? Who should have permission to grant rights to other users? Can we group users? Is there like an engineering department and all those users can go together, and planning? They will have specific rights over layers within the database. Should all users have direct access to the database? Maybe we have external clients and they should have indirect access via something like GeoServer. Maybe we should just serve out WMS layers to those users. So we set up a variety of roles. Within the database, we have group roles, which are non-login roles, and they're assigned to login users. So example would be something like the accounting department is a group role. And then we have login roles, aka users. You might hear me say users. This is pretty much what I mean. And they're typically assigned to a single end user, and they can log into the database. So example, Pam from accounting. There's also predefined roles within Postgres, but these are usually not great to use in an enterprise environment because they simply give too much access to everything within the database, such as the read everything role or the edit everything role. So important, group and login roles can be used to access any database in the server. So you can use the same roles and the same usernames to access a number of different databases. It's kind of handy, especially in like, if you have a number of different projects, you could just have the same user accessing the projects that exist within different databases using the same credentials. We're going to focus mainly on group roles and login roles, aka users. So what we created to show you this environment was a Kamloops editor group role. And these members of this group can connect to the database, edit some tables, and create new tables in some schemas. So the users Sarah and John are members of this group, and we saw this, that they had the ability to edit things like the parcel data set. The Kamloops read-only group role, members of this group can connect to the database and read some tables in some schemas. User Phil is a member of this group. So Phil does have some restrictions, and we saw that with the admin schema, right? Phil could not access anything within that schema. And then we had our super user. So that was the user, the first pane that we were looking at, that pretty much had access to everything. And I was actually connecting with my Postgres user, which is the super admin user within Postgres. So I could do anything I want within the database. So when we're creating these roles, we're just simply creating the roles, the Kamloops editor role and the Kamloops read-only role. But the big thing here is that these are no login roles. And then we grant that role to Sarah, and we also granted it to John, and then we granted Kamloops read-only to Phil down at the bottom. But for some reason, why is Sarah still unable to connect to the database? So if we had done all those things in the steps I just outlined, you would get this error. So this is one of your first lessons in using QGIS with PostGIS is read your errors. It tells you exactly what the problem is. It tells you that the user does not have connect privilege. So that would dawn on you and say, you know what? We got to do database level permissions. So this is where we're going to start. Think of this as a pyramid. At the top, we have database, then schema, then tables, then rows, then columns, and you need to give users permission all the way down that pyramid. So we're going to start with the database. So login and group roles must have connect to access the databases. Create permission gives users the ability to actually create schemas within the database. Sometimes you don't want to do that. You don't want people to start creating a schema for just random shape files that they find on the internet and slide them in. Your database is just going to turn into a big pile of mess like it was if it was in a file system. You can grant temporary, which gives users the ability to create temporary tables. You can grant revoke, and you can revoke access. We often want to revoke access to public. Public in the database context doesn't mean the public, it means any login user within the system. So typically we will revoke access to public. So what I've done here is I've revoked public, and then I've granted connect on not the individual users, but the group roles. So Kamloops editor and Kamloops read only. So now Sarah can connect to the database in QGIS, but why are all the schemas empty? And I'm sure you can guess this, is that we actually have to do schema and table level permissions. So schema level permissions, users and groups must have permission to access the schema. Users and groups can be granted create, usage, but it's important to note that granting access to a schema does not automatically grant access to the tables and objects within the schema. Table permissions must be explicitly granted. So when we grant access to the schema, we're simply saying you can access this schema, but you actually have to explicitly grant permission on the tables. So when we're looking at table level permissions, user and groups must have permission to access tables. User and groups can be granted insert, and this is where it gets more complicated. Insert, obviously, create new rows, select, you can select and see what's in the database, update, you can modify stuff, delete, you can delete rows, truncate, you can delete all rows, references, allow the creation of a foreign key constraint referencing a table or specific columns of a table. Trigger, allow the creation of a trigger on the table view. So in this case, for Kamloops editor, we granted all. Anybody with Kamloops editor could go in and delete every single parcel. Probably not the best thing to do or the best way to set it up, but this is just for a demo. And the Kamloops read-only can select anything. So that means they have read-only access to anything within all of these tables. So sequences are another thing. Sequences generate unique numbers when users are editing concurrently. So I have this problem often where a client will come and say, you know what, I granted the user access to the table, but they can't add new rows. They're having problems. They're getting all these errors in QGIS. What are the errors? I didn't read the errors. Look at the errors. It's going to tell you can't create the sequence, right? So it's used to automatically generate the unique ID values for each row. Important. If a user is going to be editing a table, they must also have access to the sequence associated with that table. Granting usage on sequences is required to use the next val function. That will actually create the next value. What is awesome about this is that you're able to, this is the core of your multi-user editing environment, is that you are going to save you're going to create a row and it's going to have an ID value of 5. Somebody else is going to save and they're going to have an ID value of 6. You're going to come back and create a new one. It's going to be an ID value of 7. Every single row will be unique thanks to the sequences. So read-only roles do not need access to sequences because they're not going to be editing or creating any new rows. So public schema is tricky. Public schema contains a lot of important objects, and we don't want to give everybody access to these. There's things like the layer styles. All the layer styles are saved within that schema. We have PostGIS functions. So editors and read-only users should not have write access to the public schema. So pro tip, limit write access to the layer styles table, or else anybody can update and modify your default styles. You don't want that. So permissions, there's really 3 steps here. So permissions on all data schemas. So we'll do this for every single schema. You can see here I did it for boundaries, but we do this typically for every single schema that's going to have data in it for the users. Permissions for all objects, we can simply do grant all on all tables and schema boundaries to Kamloops editor and so on. And then the public schema will have different set where we're only granting usage on the schema and we're only granting execute. So once we do that, Sarah now has access to the schemas, can see all the tables within, or sorry, all the layers within each one of these schemas within QGIS. Part 6, column and row level security. We showed you this, it's kind of cool. Is that this gives you more granular control over who can rewrite specific columns. This was that work order system, the column level security. So the example here is that we want to allow users to add a note. Sorry, column level, not row level, column level. This is where we can add a specific note to a parcel data set. We can edit only one specific field. All other fields should not be editable by members of the Kamloops read-only group. So to do this, we simply add a new column, we alter the table, and we add a new column called notes. And then we want to revoke all on the table boundaries to Kamloops read only. I just do that because I want to apply just some specific permissions on the table. So now what we're going to do is we're going to modify our grant for that table for that group. We're going to do grant select, but then we're going to grant update, but we're going to limit it to just this field notes on table boundaries dot property parcels to Kamloops read only. So with this, anybody in this group is going to be able to select, they're going to be able to see every single parcel, that's fine, but they're only going to be able to update the notes field. Okay, what about row level security? So this is that work order system, right? Where you would only see the rows that you've created. It controls permission on rows based on custom policies. Now, I should say that the default in the database is that if you have permission to create a table or layer, whatever you want to call it, you're the only one that's going to be able to see that table unless you explicitly grant permissions to other users within your environment. So you need to create a policy. You need to modify the existing default policy. So the policies can refer to select, insert, update, delete, or all. The policies may be permissive or restrictive. So an example is one we created. Work orders can be created by any editor, but each editor can only see the work orders created by them. So when we created this, it's a couple of steps to actually get this to happen. Is the first is I used my pretty standard metadata trigger function. And this just automatically updates certain fields within the database. I created a table, and with that, the created by field is updated by default to the current user. And then I created a metadata trigger just to make sure the trigger function goes off every time a new row is created. And then I enabled row level security, and I created the row level security policy. So I altered the table, and you can see here we do enable row level security. We actually have to enable this custom policy. Then we create the custom policy that basically says the only people that can edit a row are the ones whose username appears in the created by row. So grant access to the schema. At this point, the users still don't have access to that admin schema. So we have to explicitly grant them that permission. So we grant usage to Kamloops editor. We grant all on the table work orders to Kamloops editor. We grant usage on the sequence to the Kamloops editor. So with this, I showed you this already, is that the admin can see 2 points. Sarah can only see the 1 point that she created. John can only see the 1 point that he's created. It's really a cool system. All right, default permissions in Postgres. We have 11 minutes left. We're going to get through this, people. All right, default permissions. So the example here is we need a schema where editors can share geospatial data with other users. However, the same rewrite permissions used in other schema must be applied automatically. So this is the example. I created that share schema, and in it, I want to be able to just add data. Any of the editors can add data, and it should be available to other editors. So we create a new schema called share. We grant all on the schema share to editors with the grant option. We grant usage on the schema share to the readers. We don't want them to edit or create anything, but we want them to be able to see the stuff that gets created in there. Then we alter default privileges. So we create default privileges on the schema to permit editors all permissions on the tables and give readers select only. So any new table that would be created by user editor A is going to be visible to everybody else within the system. Here's the gotcha. Default privileges only apply to objects created by a specific role, example, Sarah. So consequently, we need to explicitly modify the default privileges for each editor by name. There's many ways of doing this. This is just the easy way that I'm trying to show you for this example. Now, grant all on schema. So we've already said that. We're going to grant usage on the schema. We're going to alter the default privileges. And notice, as I'm going through here, I'm altering a bunch of default privileges to give everybody access. But here, we're actually stating for the role Sarah. And we're going to have to do that for all of our editors. So we're going to also do that for John. So if Sarah or John create any layers within the share schema, all the other users are going to be able to see that. Really great way of sharing data. And it also allows you to add things to the database without having to go back to your DB admin and saying, can you grant permissions to the other users so they can see this table that I just uploaded? This gives specific users the ability to do that. Data auditing, we went through this already. We always ask these questions. We want to ask these questions, right? Who created the data and when? Who updated the data and when? Who deleted it? What were the row values before and after? How many edits were made in October? We can actually use these audit tables to quantify how much work is actually happening within our database. So method one, we can just create a metadata trigger, which I've done in the database. And it just collects the username and timestamps for row creation and update. It's a fairly nice system. I add it to pretty much every table that I create, just so I know when things were created and by whom. Only the last update, though, is recorded. So it's not possible to really audit edits over time. You're just basically saying, I think Sarah made the last edit, but I don't know what she changed. She was just the one who made the last edit. Now, a more powerful way of doing this is using an audit table. And it logs all insert, update, and delete actions on every table in the database if we assign this function to it. It logs before and after values. It reverts change. We can revert changes without a complex backup restoration, and we can easily quantify the number of database actions over time. And we can make cool little charts to show what's happening. We can automatically populate. Trigger functions are great because they allow us to automatically populate fields. And we saw that in the example when I gave the demo, I showed you how we could update specific fields in the database. We could update the area, and we could do a lot more with that. We can calculate area, length, perimeter. We can build complex spatial queries like spatial joins. We can conduct nearest neighbor analysis in real time. We can transform geometries. We often do this where you're collecting data in UTM, but you want to have a field that holds the latitude and longitude coordinates. Not only that, you need them in degrees, minutes, seconds. Well, PostGIS can do all that work for you. So you can create these simple trigger functions to automatically populate these fields. So the parcel area trigger function I created was really quite simple, where you're just using this function stArea on the new geometry that was just created, and I'm wrapping it all around a round function, and I'm giving it 2 decimal places. I altered the table and added a new field called area_SQM. And then I applied the trigger by creating the trigger parcel area trigger that actually just executes this parcel area trigger function, which I defined above. And just like that, you have the ability now to automatically calculate the area of a polygon. And what's nice about this is that this is triggered for both insert and update. So if you originally draw the polygon, sure, it calculates the area. If you modify it slightly, it'll recalculate the area of that polygon. All right, backups. When we are setting up backups on all of our databases, we're going to be using a combination of pgdump and pgrestore. We can often restore backups quite easily. We can just spin it up on another server or on the same server itself and access data that might have been deleted by accidents. PG dump all is handy because it dumps the entire database server. So if you have 10 different databases, a dump all will actually dump all of that. But the complexity of that, though, of course, is that then you have this giant backup file and you got to restore it on another server and figure out things. So we usually use a nice little combination of both. There's also a bunch of plugins and third-party apps available to do this. A typical sort of backup setup will look something like this. You have your Postgres server, you're going to be using dump all and dumping that to a backup server. PG dump, you're also going to be throwing that into a backup server. We'll typically run backups daily on all of our servers. And then we're going to spit out an encrypted file from our backup server to two offsite locations. Both of which, or one of which, we are actually going to move files offline, which is the safest way to store these data. All right, QGIS integration. We talked a lot about this, and I won't dwell because we're coming close to the end, but we already showed that, you know, different levels with different users with different levels of access can do different things, right? So whatever permissions we establish within the database, QGIS will actually work differently for different users. We looked at the admin schema, and we could see that, you know, Sarah only had the ability to see one file, whereas Phil could not see anything, couldn't even access the schema, whereas the admin could see everything within that schema. We talked about concurrent editing, allow multiple users to edit the same layers concurrently. You know, we can press that refresh button and always see new layers yet. But one thing to always note is that last save wins. And I preach this a lot to my clients, is that if you have multiple people editing something, the last one will win. So if one user deletes 10 rows, but hasn't pressed save, and you know, if another user saves before them, their changes are going to be saved before those deletions. Versioning is possible through Postgres. We can also create some custom functions to do pretty much the same thing if we need to. Centralized vector symbology is important. Save default symbology. We saw that already with the whole Kamloops data, is that, you know, all those default styles can be saved in the database and accessible by all users. We obviously want to control who has access to the layer styles table that lives in the public schema. We want only a few people to do this. So permissions on this table can control who can read, insert, update, and delete styles. For the most part, we want users to simply be able to select on this table. We can save projects on the table within the database. This is handy. You can have your Kamloops base map saved directly within the map schema. It's really nice to be able to style. You can create your whole map layouts, save them within the database, prevent users from modifying those projects, and every user can simply go in. So think more about like the read-only users, right? Those people who are going to log in, they're going to look for a specific parcel data set. They zoom in, they press the print button, they get the print layout already set up the way you have it set up. Nothing's going to be modified within that project. If they accidentally delete a print layout, it doesn't matter, because if they try to press save on the project, it'll throw them an error. So for these users, this is really powerful to have this as a central point where you can access all of these maps. All right, custom forms. I love it. We can create multiple tabs. We use these all the time. And we saw, like, I gave you a little brief demo, but this form in front of you shows you quite a more complex form that we can create with a whole bunch of drop downs, check boxes, pick lists. You can do numeric input, date input. If you have foreign keys set up in your database, you can even pull values from another table and have them show up in your drop-down menu. The list goes on. So that's it. This is your enterprise environment. I gave you an idea of what this would look like for a kind of data warehouse type situation, right? Where we're putting everything in the database. But this is that's really the most basic type of multi-user editing environment that we set up. Oftentimes we'll set up a database like that for a client that also has project-based databases. So that's where their day-to-day data will take place. They're going to be editing all of their project data in a separate database, but all their base map data is going to live happily within this sort of data warehouse database. So one thing we're offering for all of you who've come to this wonderful webinar is we're offering a sort of spring savings on trying open source GIS. I always say that especially for people who are migrating from other databases or other GIS solutions, they have to try it. You have to try this. You have to set this up. So what we're offering is the opportunity. We'll spin up a server for 3 months. You get to play with it. We do 3 training sessions with you. We do a basic implementation. Give us a bunch of layers, we'll throw them on. Give us a bunch of aerial photos, we'll throw them onto GeoServer. We'll set up your base map for you, set up some default styles, and walk you through the process of doing all that. We'll do 3 group training sessions with you. You could bring a bunch of staff in. You could do it just with your like core GIS staff if you want. We'll do weekly Q&A sessions that really don't count towards your support, and we'll throw in like 10 hours of support that you can use however you want. If you want to use that just for developing something neat within the database to see if it's possible, we can put that time towards that, or we can just answer questions for you as you try this. But this just gives you 3 months to tinker with this stuff to see if this is right for your organization. So the other thing I'll say is get in touch with me. You can use contact@lunageo.com. or email me directly if you want. But this offer does expire on June 15th, and we've given out a bunch of these already. So I would jump on that. If you are interested, send me an email, just let me know, and we can talk a little bit more about this. So questions, I see 2, I will get to them. And if you have any questions that you don't want to ask now or come up later on, feel free to email me, cpatterson@lunageo.com. I'll be happy to chat with you about anything, especially if you're interested in the server offer. I'd love to talk about how this could be used in your organization. Okay, anonymous attendee. How can you prevent the audit tables from bloating? Ooh, good question. If you have an overnight script that makes millions of record changes every night, can you clear or compress the audit table? That's a really good question. I haven't confronted that issue, but how off the top of my head, yeah, you could definitely unload the audit table, export it out to like a CSV file and just store it like any other log file. So you could have a nightly script that just downloads, exports the audit table to a location that's obviously being backed up, save it as a CSV file. It's safe, it's there if you need it, and then blank out the audit table. That would probably be the best way of handling that if you're dealing with a lot of changes on a daily basis. Are all the sequence tables used in demo available in documentation somewhere? Where can I find these references? I will be dropping all of this stuff. We are currently upgrading our blog platform. Our blog is not fully populated yet, but I'll be throwing a lot of this stuff on there if you want to take a look at that. So I'll make that available to you. All right, let me just make sure that I'm not forgetting anyone. Oh, Q&A. All right. If there are no other questions, I'd just like to thank everyone for coming. Oh, chat, holy moly. All right, I just realized there's a bunch of questions in chat that I will now address. QGIS, okay, can we implement database versioning here? Yes, we talked about that. Yeah, there are plugins also for that. It's a more complicated answer, but yes, it is possible to implement some sort of versioning within Postgres. What database version? I think it's 3.28 or something. I forget the exact number. Sorry, David. John, can we also implement quality assurance before the data is stored in the database? Well, yeah, I didn't get into that, John, but that was one of the things actually as I was going through this, I thought constraints. I should have really talked more about constraints, but I think we would have been here all day if we got into constraints. But yeah, on every row, we can control what values are being inserted. And that's a huge part of setting up a multi-user editing environment, is to say, you have to put an integer. So data type is your first line of defense, right? You need to put an integer in this field. You need to put a decimal. The number cannot be higher than 62. The number cannot be lower than minus 78. You can establish all of these constraints. You can only insert yes, no, up, down, left, right into this field. You can do that through a foreign key constraint. All that is something that we incorporate into the databases we build. The minute a client says to me, we're going to be collecting data in this database, my eyes light up and I say, well, we have to talk about constraints. So yeah, thanks for mentioning that, John. That was really important. So yeah, that does validate. The database will validate as you're trying to insert. Oh, thanks for all the nice things all of you are saying. This is great. I'm glad you enjoyed it. Thank you very much. If there are any additional questions, feel free to reach out. I'm happy to jump on a chat too if you want to have a chit chat about some of this stuff. I will try to make everything I put in this webinar available on the blog in the coming few months. I promise. I have most of these written, and I'm trying to turn them into something bite size. So there'll be something on like watch for it. It'll be like on row level security. If you sign up for our newsletter, make sure you said yes to that when you signed up for the webinar. You'll get a notification. We'll put that all over our newsletter once we start putting those out. Thank you very much, everyone.